So, am I audible to you guys? One moment is all I need. Love, love, love. Hello, guys. So, yes, am I audible to you? So, yes, am I audible to you? यस हाँ यार हूँ मैं जरूर हूँ सबको ऑडिबल पूरा दुनिया सुन रहा है दोस्त आराम से बता सो हेलो गाइस बिफोर वी गो एनी फर्दर दिस इज अ स्टैट्यूटरी वार्निंग जो हम हर दिन देते हैं देयर इज अ वायरस इन प्रोग्रेस इन द एंटायर वर्ल्ड not just the country not just the city not just the state not the entire world okay so till you get a proper uh, vaccine I want all of you guys to stay safe stay at home all right I want you guys to stay at home and stay safe and be good like this guy मतलब ये जो बंदा है उसकी तरह बनो and while you're staying at home crack IIT-JEE with India's largest platform which is Unacademy. Yes, you got it right. Get the plus subscription using the code NSS1 to access unlimited live and recorded sessions from India's best educators. Not just one or two, but पूरे मतलब सबका मिल जाएगा. It's not like a local college. यहाँ पे तुम एक बार सब्सक्रिप्शन लिया तो you'll get all teachers who are in the Unacademy platform. So pretty cool. Use the code NSS1. And hello amigos, I am N Srikant. I did my BTech from IIT Kharagpur with an AIR of 385. I've been guiding young minds for the last 4+ years. You guys call me a human calculator. Yes, I'm a sandwich. I am a Sunrisers fan. Sunrisers forever. And DC is equally marvelous, if not better. मतलब DC का DC का fan हूँ मैं. I'm a big fan of Joker. Anything you would like to say or put it in this, put it in the comment section below. Don't forget to like and share this video everywhere. This is Let's Crack JEE in English. Let's Crack JEE in English. So this is a special channel for those of you guys who have trouble understanding Hindi. तो मैं यहाँ पे हूँ आपको इंग्लिश में सिखाने के लिए ठीक है और ये this exact thing I told it in Hindi but yeah that's the irony of it. So let's crack JEE in English is a special channel for you guys. So let's go for it. This is how the app will look. Definitely install the app right away and definitely we have loads of quiz shows and loads of fun happening there. Today at 10:30 p.m. there's another quiz which is happening. It is about IPL. Yes, you heard it right. We have an IPL quiz there happening today. So stay tuned. We'll have loads of fun. All right. So today's topic, this is the 9th lecture of magnetic effects of current, and today we'll be talking about the magnetic dipole moment. मतलब magnetic dipole moment क्या होता है? What is it? And everything about this we'll discuss today. Okay. So before we go any further, we know force acting on a current carrying wire. What is the force acting on a current carrying wire? It is equal to Q into V cross B. Before we go further, this is what happened yesterday. The force acting on a current carrying charge is Q into V cross B, and the force acting on a wire will be given by I into L cross B. So this is the force on a current carrying wire. It is given by L cross B. So now let's go into the magnetic dipole moment. Now ये क्या है? Magnetic dipole moment क्या है? Let me tell you. As we keep discussing, there is a lot of similarity between electric dipole moment and electric charges and magnetic fields. Remember electric field और magnetic field का काफी similarity था. Like there you had Gauss law, here you will have Loops law, Kirchhoff's loop law. Similarly you had lot of other stuff which were very similar on both sides. We discussed this exactly yesterday when we were discussing about force on a current carrying wire and so on. Okay, so exactly in the same way magnetic dipole moment can be linked with electric dipole moment. It is very similar to electric dipole moment. There are many ways of writing magnetic dipole moment. Sometimes it is represented by m, or it is also represented by mu vector. Both of them can be discussed. Like we know, electric dipole moment was a vector. Similarly, magnetic dipole moment is also, the dipole moment is a vector quantity. Alright, it's a vector quantity. इसको direction है. What is the direction of it? We'll figure out as we go. Basically, I will tell you the direction of dipole is very similar to electric dipole. What if I say dipole moment magnetic and dipole moment electric are the same? मतलब एकदम same है. Electric dipole में क्या था? Electric dipole. Let's look a little into electric dipole before we go here also. Electric dipole moment जो P था वो कितना था? When there is a charge plus Q and minus Q placed, minus Q and plus Q placed, separated by distance of let's say 2d. 2d क्यों बोलते हैं? क्योंकि सेंटर से दोनों का dd मान लेते हैं. So in this case the dipole moment was given by 2qd along the direction from negative to positive. The direction was always given from negative to positive. ये direction में dipole moment माना जाता है. The direction of it is along. Direction of it is not along. It is towards positive charge. ऐसे towards positive charge, and the magnitude was given by 2 into q into d. Now we can also imagine magnetic dipole to be very similar to this. So basically magnetic dipole moment matlab it can be happening because of anything. Okay, so we will just say magnetic dipole moment ये कैसा, how is this possible? Like so suppose there's a north pole and south pole. मतलब एक magnet ले लो. Let's take a north pole and south pole. So what is, how is it happening here? Let's take the separation between them to be like some L or something. And यहाँ पे दोनों का यहाँ पे m और minus m ले लो. The moment. So this can be taken as pole strength, where m is the pole strength. This is pole strength. So in this case, we can just directly say that. So one more thing before we go any further, we'll discuss a little about field lines. How do field lines travel? यहाँ पे field lines go from positive charge to negative charge. Similarly, here also field lines start from north and end in the south. You know, this is how it goes. Just like यहाँ पे ऐसा था. Starts in positive, ends in negative. Similarly, here also it's starting at north and ending in south. So from this we can say the positive charge is north and the negative charge is south. The magnetic dipole moment, I hope you're understanding it. The positive charge will be along the north pole. Just if we compare both of them, the positive charge will be north and the negative charge will be south. And the magnetic dipole moment mu or m vector, I'll use m whenever I am writing, mu whenever there is an image there. So magnetic mu or m will be given by m into L along north direction. So this is one way of writing it. The main difference though, the main difference you will find here, the main difference between magnetic dipole and a normal electric dipole, the main difference, similarities abhi tak dekhe hain. We saw the similarities. What are the similarities? They both will have the same p into total distance, 2q into d. So यहाँ पे भी अगर मान लो ये 2l 2d मान लिए, तो ये भी कितना हो जाएगा m into 2d, or you can also say 2md, where m is pole strength, just like magnitude of charge. M is pole strength and d is half of the separation, midpoint to end. Just like here, मतलब यहाँ पे भी ये charge magnitude है, and this will be half distance. So and towards the positive charge, here also along north from south. Alright, so you are able to understand the similarities between both of them. Alright, bahut badhiya. This is an awesome session. So इसमें this is so far we've got this, but let's see what the differences are. में differences क्या हो सकता है, क्या हो सकता है बताओ. So one thing you know, there can exist individual positive and negative charges. There can exist individual positive and negative charges. मतलब positive charge in real life you will find. Similarly, you will also find negative charges in real life. Exist individually. There can exist individually positive and negative charges. But can a single pole exist uniquely? No. But a single pole can never exist. Single pole can never exist. ये बहुत important main difference between electric field and electricity and magnetism is that a single pole will never exist, but single charge can exist separately. All right, and poles are never single. So it means to say that there is never, poles are never single. मतलब you can never catch a north pole separately. North pole does not exist individually. ये बहुत major difference है. This is where the main thing is there. So that is the major difference between magnetic pole and and electric dipoles. So इसमें how do you just imagine the whole situation? Let's see. इसको थोड़ा बैक करते हैं. So ये point है, major difference is that they cannot exist in a single plane. North pole cannot exist alone. No pole can exist alone. Okay, so now if you want to imagine how the loop, hello Sairam Garu, hello, good evening Amma. So now you take a current loop. Now you can just, now how to discuss the magnetic dipole. Let's take a current loop. आराम से current loop को लेते हैं. So in current loop we will take it like magnetic north pole south pole कैसा होता है उसी टाइप से. So now let's take the direction to be anti-clockwise. ऐसे anti-clockwise direction है, तो इसका मतलब what is the direction of magnetic field? The magnetic field will be upwards. If the current I is flowing in anti-clockwise direction, the magnetic field will act upwards, which means how will the field lines go? If you draw a little about field lines, the field lines will go from inside to outside in this particular direction. This is subject, there will be field lines flowing, right? So this can be compared with a magnetic field. How? This can be compared with a magnet. How? We understood the comparison between magnet and electric dipole. Magnet, the magnetic north in the magnet is equal to positive charge. You can imagine it this way, is equal to positive charge, and south can be taken to be negative charge. So how can you link between any field, any current carrying loop and a magnet? Now we will link between current carrying loop and magnet. In दोनों का what is the relation we can get? Look at this analysis of this. And so if you observe this carefully, thoda matlab imagine this wire to be giving magnetic field. Imagine wire not as a 2D body, imagine it like a 3D body. So if you can imagine this same thing, I will draw little differently. Matlab thoda halka sa, if I just draw one pole magnet like this, instead of this if I draw a magnet like this, which is causing the same field. This magnet is causing the same field. So how will the field go? It is going out like this and it's coming from inside like this. No, if it's going out from this end and it is coming in from this end. So in this particular case, when the field lines are going this way, how can you imagine the direction of north and south? We already know that field lines originate at the north pole and end at the south pole. So using the same logic, we can use this field will be similar to this. Both of them are the same one and the same thing. As shown in this particular diagram, when the direction of the direction of current is anti-clockwise as shown here, the direction of magnetic moment will be along the direction of north. Whatever north is there, that is the direction of the thumb. मतलब when you use the right hand curl rule, when you use the right hand, sorry my bad, when you use the right hand curl rule, the direction of the sloop will point towards a particular direction. That direction will be where the north is present. मतलब यहाँ पे फील्ड लाइंस ऐसे जा रहे हैं तो ऊपर जो है वो नॉर्थ है, the bottom will be south, exactly like as shown. So this can link between a magnetic dipole moment and a magnetic field. So magnetic field मतलब magnetic current carrying loop. This is the relation between magnet and current carrying loop. Current carrying loop. All right. So the magnetic dipole moment. अब direction तो समझ में आ गया. Direction is given by right hand thumb rule, like as shown in the GIF below. So the direction of magnetic field will be outwards. So this part will be taken to be magnetic north. इसी side से everything is coming out. So this side will be taken as magnetic north, and this bottom will be taken as magnetic south. All right. So now similarly here also the direction of mu will be coming outwards. And what is the magnitude of mu now? Now let's discuss about the magnitude of mu. Just give me one page. The magnitude of a dipole. Magnitude of magnetic. So direction, the magnetic moment's value, the magnetic moment mu or m is defined as I into area vector. Area vector, what is area vector? The area vector is the exact thing we discussed before. So it behaves exactly like you curl your hand along the direction of current, the direction of thumb will show area vector. Thumb in right hand curl on loop. On the loop gives direction of area vector. ये पता होगा मतलब direction of area vector will generally be perpendicular to the area plane. It will be perpendicular to the plane of area and coming out based on the direction of current. You the direction of your hand curl, the thumb, right hand thumb will give you the direction of area vector. So this now, if you observe carefully, you can also say when a body is moving in clockwise anti-clockwise direction as given here, the direction of magnetic field will act outwards. As a result of which, this will be equal to a magnet which has north on top and south on यहाँ से सब बाहर आते हैं और यहाँ से सब अंदर जाते हैं. This is how the field lines go. So similarly here also the field lines will come outside and so on. And same way if you inverse the direction of the current in the loop. So similarly the polarity will reverse. When you reverse the direction of current in loop, the polarity will reverse. When direction of current is reversed, why no? Obviously, है ना? Because once it direction of current reverses, the right hand thumb direction becomes ulta. Then the magnet flips direction. So this is one major understanding, guys. All right. So now we'll look a little into the properties of this magnetic field. So what is the meaning of properties of this magnetic field? It is given by mu vector is equal to I into area vector. All right. It is given by mu is equal to I into area vector. It is given by the product of current and the area of cross section. Alright, so इससे क्या पता चलेगा? Mu will be proportional to I and mu is also proportional to area of loop carrying current. Alright, so now the main definition of it is mu is I into A vector and the direction is found out by using the right hand thumb rule. So एक simple सा example करते हैं. Let's find the magnetic moment of this particular diagram. Find the magnetic moment of the current carrying loop shown here. Simple hai. I want you guys to understand the direction also properly. So the value of mu is given by I into area vector. What is the area vector in this particular case? It's a circle, right? It's a circle, so area will be how much? Pi into r square. So what is the value of mu given now? Mu will be equal to I into pi r square. And what is the direction? As you see clearly here, it is undergoing anti-clockwise direction, so it is outside the page. It is coming outside the page, matlab is direction it is coming out. So what can this direction be called now? This direction which is coming out is nothing but the direction of k cap. The direction using the right hand loop rule, it's counterclockwise. Anti-clockwise hai to outside hai, which implies the direction is k cap. So from this you can say mu vector will be equal to pi I r square. Pi I r square. So the value of mu is given by pi I r square. Great, awesome. एकदम समझ कर दिए. Now let's go into little different. बहुत simple है but the same thing. Find the magnetic moment. Find mu in this particular diagram. So इसमें what is the direction of current? If you're seeing from top, it is undergoing anti-clockwise rotation, which means the direction should be outwards, which is coming up like this. So directly हमेशा first we can find out the direction of current. First I will say the direction of current will be given by right hand curl rule, which gives us what particular direction here? It is giving us j cap direction, which is vertically upwards. As shown here, you loop your hand in the direction of current with your fingers, and the direction of thumb will show the direction of magnetic moment. This is given by this, and magnitude is given by what? Will be equal to current into area, which is given by I into area of this whole thing. Area of this whole thing kitna hoga? What is the area of this whole thing? It is nothing but it's a rectangle. One side A, one side B. This side B A hoga, this side B hoga. So area of triangle will be given by IAB. So from this we can say the magnetic moment or mu is equal to IAB. The direction given by J. Is simple. So if you like this, definitely don't forget to hit the like button and share this video everywhere. Make this viral. We got to spread this word everywhere. चलो अब this is a next level question guys. मतलब यहाँ पे how do you solve this problem? There is a very nice trick to this. So naturally what the simplest method we'll do is we just take them, we'll find the total area of cross section of the entire thing, but in this case area is divided into two parts. In this case area is along two planes, so it is not fixed. It is not fixed about one particular plane. It is varying across two different planes. One in the IJ plane, one in the IK plane. All right, one is in the IJ plane, the other is in the IK plane. So in this particular case, इसमें एक simple सा trick I'll use. I will take the current to be flowing in both directions, one along this and one along this. All right. So now the upper part will have one loop and the lower part will have one loop this way, and the upper part will have another loop this way, where the same current I is flowing across the entire thing. So now we have two planes. One is plane 1 and the other is plane 2. So I'll take the area of 1. In the first case, what is the total magnetic moment of this? Magnetic moment 1 will be given by I into area of the whole thing. What is the area of this whole thing? Again, height A, B hai. side A है, तो it will be I into AB, and the direction, since it is moving in anti-clockwise, it's coming outside. What is the meaning of coming outside? Coming outside means it is along the direction of k cap. And similarly, the second one will have mu2, which is equal to I into A into B only. And the direction of this is anti-clockwise again, so the direction of field will be out upwards, which is equal to j cap. दोनों को add कर दे, mu total will be equal to mu1 vector plus mu2 vector, which is given by IAB into k cap plus j cap. So the magnitude of this is, magnitude of mu will be equal to root 2 IAB. So yes guys, this is how it is. So wonderful, great job. Now for the next question, compute the magnetic dipole as shown in the figure here. So how do we solve this question? It's very simple, no? It's simply area of the loop. There is multiple ways of solving it. One, you can take it as single half loop and multiple half loops, or you can simply write field will be equal to I into area vector. And in this particular case, area vector is circling it downwards. There is multiple directions, so we are not sure about how directions we should take. So what I will do here is, I will take it as sum of the outer radius R1 plus this plus this. So in this closed loop, so I can say the total moment, magnetic moment will be equal to I into pi by 2 R1 square, and the direction of it is inwards. Inwards is minus k cap plus I into pi by 2 R2 square plus k cap. Because the direction is anti-clockwise here, it's coming out. Here direction is clockwise, so it's going in. So you can add both of them. What will you get the total magnetic moment to be? I into pi by 2 into R1 square minus R2 square minus k. So this is the total magnetic moment, magnetic dipole moment of this particular wire. So yes, now for a very nice and tricky example, इसमें क्या करेंगे? इसमें there is multiple ways of solving it. I'll tell you a very nice trick here. It will make your life so much more easy. So generally you have to find the area vector. Here we can find that out. We can say this area vector will be perpendicular to this. So to make it simplistic, this is the area vector starting here. So if I can take this angle to be perpendicular to it. I can find out the unit vector along this direction, and I can solve accordingly. Okay, so let's do that in the first method. The first method, when I solve, I will take the area to be, area vector is equal to, it's along this direction. So if you look at it carefully, the direction is again anti-clockwise, so it will be forward, upward in this direction. This is the direction of area vector. Since this angle is theta, this angle will be 90 minus theta, and since that angle is 90 minus theta and this is 90, this angle is theta given by this angle also. So I can say area vector can be written as a cos theta I cap, a cos theta I cap minus a sin theta k cap. क्योंकि इसमें एक डायरेक्शन इसमें है, one of it is along this direction, this theta here, so the other component is along this direction. So this direction is a sin theta, given by this direction is a cos theta. So I can see, now I can write off magnetic moment will be equal to I into a cos theta I cap minus ia sin theta. So मतलब इतना थोड़ा confusing है ना. So the best simpler method of solving this, the simpler method of solving it is, I divide this into two parts. One along this particular direction and one along this particular direction without changing any flow of current. Here the current will act in this direction because the part of it is going backward. Similarly here also current will act forward. So now the magnetic moment I can simply solve off by using this logic, where I will say अच्छा इसमें डायरेक्शन ऑफ करंट उल्टा है तो इसका एकदम उल्टा हो जाएगा, एस आई कैप प्लस के कैप माइनस के कैप. So using these same logics, now if I solve the problem, this is one with side A and A sin theta. This is one with side A and A cos theta. So for here the magnetic moment will be going inward this way because it's curling that way, and it will be equal to I into A square cos theta. In this particular case, area kitna hai by the way? Area is given by A square. So I'll substitute this here. I will get B is equal to I A square common le lo minus cos theta I cap plus sin theta j cap. Sin theta k cap. This is the previous question. Now let's solve this here. So the area of will be IA square cos theta, and here it will be coming out, and it is given by I into A square into sin theta. So the total magnetic moment in this particular question will be equal to IA square cos theta I cap minus I cap plus IA square sin theta k cap. Is it the same thing we got? Ekdam. So we got the same thing in the left hand in the previous method using area vector as well as splitting area vector. So we can also say we can split area vector into multiple pieces. Split area vector into multiple pieces and add them vectorially. And add them vectorially, matlab vectors you can add off vectors. That's what I mean to say from when I said vectorially. Alright. So great. Chalo, now let's go. So this marks the first half of this class, guys. Matlab, let's crack IIT-JEE with India's largest platform, which is Unacademy right now. Get a plus subscription to access unlimited live and recorded courses from India's best educators. So get the plus subscription using the code NSS1. Using the code NSS1 to get benefits like Amazon. Like Amazon में जो होता है उस type का benefits मिल जाएगा आपको. So yes, go for it right away, guys. So what do you get with plus subscription? With plus subscription, you get the best of Unacademy. With plus subscription, you get the best of Unacademy, best that Unacademy has to offer. So you get the best of Unacademy. Matlab, what is the best? You get daily live classes where you can chat with your educator, engage in discussions, ask your doubts and answer polls all while the class is going on. Matlab, engaging in discussions and doubts sub dynamically ho jayega. Just like in this particular case in this channel, you cannot ask doubts very quickly. There's a little delay. There's a little delay or lag as we see. So it is very tough to have for this to happen, but using the plus subscription in the Unacademy app, you can engage with discussion in live. Okay, not only that, you get live tests and quizzes where you can evaluate your performance with regular mock tests and quizzes and get detailed analysis on your performance where you can see which question you did right and which question you answered well. What is the time taken for each question? You get a lot of analysis, which I generally want you guys to generally perform otherwise, that I used to tell in the classes. But then now with Unacademy, it's already giving it to you. And not only that, you get structured courses where all the courses are structured in line with your examination syllabus. मतलब जो syllabus है उसी के एकदम topic by topic, section by section, chapter by chapter, subtopic by subtopic, all of them will be given एकदम in a detailed manner here, where you get structured courses and unlimited access. With one subscription, you get all live and recorded courses from across the country, from everywhere, all from the comfort of your devices. It's a pocket dictionary or pocket library, if you want to call it. So what does Joker say? When you're good at something, never do it for free. That's why Unacademy is charging a nominal charge of 38,500 for 1 year, 28K for 6 months. Okay. But if you use the code NSS1, you will get a 10% off, and this will come down to 34,650. This will come down to 25.2K. Now this might sound little big, but if you divide it to per day basis, which you should be studying regularly, if you divide it into a per day basis, that this comes out to 32 rupees per day on physics, chemistry and maths. 32 rupees per day is like nothing if you're studying for even 1 hour a day. This is like a golden opportunity, guys. I think you should go for it. Not only that, if you take this is for those who want to crack JEE 2022, use this code NSS1 to get 56,000 a cost generally. But if you use the code NSS1, you'll get it for 50,400 only for 2 years. This comes out to 23 rupees per 23 rupees per day on physics, chemistry, and so what are you waiting for, guys? Ekdam kar lo, macha do. Definitely use it. Not only this, iconic subscription has been launched by Unacademy, especially for those guys who need help from teachers. I know a lot of students used to take a lot of help from teachers when they were preparing for JEE, but now since there are no teachers, a lot of them are in turmoil ki they don't know how to prepare. So Unacademy's this has launched a personal coach along with the plus subscription, where the personal coach is a one or is a guidance expert from top exam is a top exam expert. So he will give you personal preparation strategies, which is individual to you. Matlab everything will be analyzed based on your individual performance, and it will be given to you by the personal coach you will be hiring. Not only that, test analysis will be there where you do use in-depth test analysis with personalized feedback to improve time management and exam approach. Um, and you also have a study planner where you can ace your preparation with customized study plans. Based on all this test analysis will be given with which chapter you're doing well, which chapter you're doing slow, fast, all those things. And the personal coach along with this test analysis will give you a study planner based on how you are performing on a weekly and bi-weekly or anything of your comfort. Not only this, you get all the benefits of plus also along with this. Awesome scenes, man. Awesome sauce chal raha hai yahan pe. So the cost of this is a little more. No, it is 56,000 for 1 year, but if you use the code NSS1, you will get it for 50k. This is coming out to 46 rupees per day for physics, chemistry, and maths for 1 year course. Matlab, if you want to crack JEE in 2022, you can take the 2 year subscription, which costs 86k. But after using the code NSS1, it comes down to 77,400. This comes out to 32 rupees per day on physics, chemistry, and all this with a coach. So matlab it's pretty awesome, guys. I think everyone should go for it. So now let's talk about the magnetic moment of a moving charge in a loop. A charge is moving in a loop with velocity v and radius r as shown in this particular diagram. So what happens when this is the condition, when this is the situation there, what will happen to the, what is the magnetic moment? So one thing we know, magnetic moment is defined as I into area, right? So area of this I can already directly say is equal to pi r square, and since it's moving in clockwise direction, I'll tell it is outside the page. I'll give a direction like this, or I can also call it as k cap, but I will give the direction dot. The direction is a dot. All right. So yes, the area we found out. So what is the current now? Current is the rate of charge flow. Rate of charge flowing across a unit cross section area, across the cross section of the wire. Per second. It is rate of flow matlab per second, per time ही होता है. Generally when there is a rate of flow, it generally happens with time only, right? So now if you, it's nothing but the total charge flowing here. If the given charge is Q, the total charge flow per unit time can be given by velocity of the particle into time is the total distance. So look at this, per unit time the total distance traveled by the charge is v, all right, and the circumference is 2 pi r. Distance traveled is v and the circumference is 2 pi r. So इससे frequency कितना आएगा? The frequency is the number of times the charge moves in 1 second. Number of times charge rotates in a second, which is given by v by 2 pi r. So ये हो गया the value of frequency. So what is the now? What is I now? I will now be equal to frequency into charge, which is given by q v by pi. We got I, we got area. So using both of them, what can we solve it? By saying magnetic moment will be equal to I, which is QV by 2 pi r into pi r square. इससे दोनों से क्या आ जाएगा? QVR by 2. This is the magnetic moment of a current carrying loop. Any Q can be anything. Hello Siddeshwar, good evening man. हाँ आज थोड़ा लेट क्लास कर दिया बिकॉज आई एम प्लानिंग टू शिफ्ट टू अनदर चैनल ऑल्सो. उस चैनल में भी हम करेंगे वीडियोस फ्रॉम टुमारो at 8 o'clock. So I was thinking how the time will be there. That's why I was doing it for the last 2 3 days. From tomorrow we are starting off nuclear physics. By the way, I'm very excited to start it. So definitely ये almost ending part में आ गया magnetic field due to current and force, the magnetic effects of current carrying wire and all these. So I will start off nuclear physics in a parallel channel. Let's crack JEE. तो उसमें टाइमिंग यहीं पे रखने वाला हूँ. दैट्स व्हाई यू गॉट इट. लेट्स क्रैक जेई. लेट्स क्रैक जेई मतलब थोड़ा डिफरेंट चैनल है. देयर यू कैन आल्सो डू दैट्स हिंदी. इट्स अ कॉम्बिनेशन ऑफ हिंदी एंड इंग्लिश चैनल. So definitely stay tuned to this for further updates. So now we understood the magnetic moment of a moving charge in a loop. ये लूप में ऐसे 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 घूम रहा है. तो दैट टाइम वी गॉट द करंट टू बी इक्वल टू QV by 2 pi r and the area vector to be pi r square in the dot direction. So using both of them, we get magnetic moment is equal to QVR by 2 in the outward direction since it is flowing in anti-clockwise direction. All right. So now magnetic moment of an electron in Bohr's orbit. ये काफी commonly discuss कर चुके हैं. मतलब it's a very good topic to discuss. So we will be discussing about Bohr's orbit. मतलब Bohr's orbit में क्या क्या inferences उन्होंने डाला है इसमें. So in this particular case, you can use the same formula, only that the charge will be equal to minus E. Minus E, or you can also say minus 1.6 into 10 to the power minus 19 coulombs. ऐसे भी बोल सकते हैं. You can also use this. The magnetic moment of an electron in a Bohr's orbit will be given by the same logic. The magnetic moment or mu is QVR by 2, right? So you apply the same thing here. If a particle is moving with velocity v and having mass me and angular charge of minus c in the r direction, if it is moving in counterclockwise, यहाँ पे if you observe it, the electron is moving in counterclockwise direction. So the mu will be equal to q into minus e, q minus e, sorry, minus e into v into r by 2. What is the answer we are getting? EVR by 2 is the magnitude, and the direction is given by, if it's rotating anti-clockwise, generally it will be upwards, right? But since the charge is negative, the direction of field, the magnetic moment reverses. Like we already discussed, the direction of current, if it shifts, the direction of magnetic field reverses. Similarly, the direction of electron movement means it's the opposite direction of positron moving. This can also be equalized with a positive electron moving in this direction with V. तो ऐसे ही भी imagine कर सकते हो. So this way, if you see, the direction of actual current will be clockwise. The direction of current is clockwise. So I will say the current is moving inward, and the magnetic moment is given by EVR by 2, where V is the speed of the particle, R is the radius, and E is the charge. All right. Okay. एंगुलर मोमेंटम ऑफ अ बोर्स ऑर्बिट. नाउ एक बार एंगुलर मोमेंटम का भी देख लेते हैं. वी कैन आल्सो डिस्कस एंगुलर मोमेंटम. व्हाट इज एंगुलर मोमेंटम? L. It is given by mvr, right? Generally when a particle is moving with velocity v in an orbit of radius r, then particle of mass m is moving with speed of v in a circle of radius r, then angular momentum is given by mvr. Again similarly the direction will be given by right hand thumb rule. Right hand thumb rule will give direction. Alright, जैसे कि इस टाइप सेम एग्जांपल है, the same diagram. So in this particular case, charge is moving in this particular direction. Right hand thumb rule, direction of current and field and moment. Clear? So इसमें, So this is the direction of current and angular moment. So angular momentum will now be given by how much? mvr is the angular momentum. That's it. Mass is the mass of electron, v is the velocity, and r is the radius. So this can be defined very easily. Now if you want to find the relation between angular moment and magnetic moment, what can we figure out here? Okay. So one thing we know, angular momentum L is given by m into v into r, m into v cross r exactly, and angular momentum B, mu, is given by. So before we go a little further, I want you to understand the direction. The direction of this will be minus k cap since it is moving in anti. So the direction of angular momentum will be in k cap direction here because it's moving in counterclockwise as shown. The direction of angular momentum will be in this direction. But because charge is negative, we got direction of field to be in the opposite direction. Okay. So that is the main thing. So now if you want to find the relation between them, mu will be given by, what is the value of mu given here? It is given by q v r e by 2. V r e by 2. And the direction of this is k cap and the direction of this is minus k cap. Oops, sorry, this is k cap and this is minus k cap because the charge is negative. So we can, using these both, we can also find the relation saying क्या relation यहाँ पे VR common ले लो. L by m will be given by mu by 2 mu, मतलब इसको सबको 2 mu by e. So this is the relation by taking is equal to VR. So you can link these both. What can I say? The ratio of magnetic moment by L, angular momentum. Both of them are along same direction. So I won't do vector division. तो इसको क्या बोल देता हूँ मैं? I will say this is equal to E minus E by 2m into L vector. Where this is the charge of the electron, this is the mass of the particle. The charge and this is mass. So this is how we can relate between both of them. ये बहुत शानदार relation है. So we can also say the magnitude of mu by magnitude of m. Magnitude of m नहीं, L by ये क्या है? L ही है. Will be given by E by 2m. So I hope it's clear to you guys. The ratio, this is a very useful concept. Generally in Bohr's orbit, we also use this concept, right? In general, Bohr's orbit, we generally use the concept angular momentum will be equal to nh by 2 pi. तो ये जो ऑलरेडी है तो इसको हम वी कैन ऑल्सो फाइंड आउट मैग्नेटिक मोमेंट इन बोर्स ऑर्बिट. ये n क्या है बाय द वे? n इज द क्वांटम नंबर, n इज द नंबर ऑफ इट कैन बी 1 2 3 4. ये 1 क्या होता है? 1 ये सब ऑर्बिटल्स होते हैं ना, k l m n करके, मतलब you have this in chemistry already, 1 2 3 4 and so on. This is the numbers we'll be using here also. The same numbering will be used here also. All right, so we'll apply this here. Now we can directly say mu vector will be equal to minus E by 2m into nh by 2 pi. So from this what we'll get? The magnitude of mu, if I want, it will be given by h e n by 4 pi m. This is a very nice formula. मतलब ये काफी जगह you have to remember this. इसमें right now we derived it so that you can not remember it. It is by 4 pi m, 10 by 4 pi n, where h is Planck's constant, which is given by 20 by 3 to 10 to the power minus 34. And E is the charge of an electron given by 1.6 to 10 to the power minus 19. Baap re. M is mass of electron which is given by 9 to 10 to the power minus 31. And pi is an irrational number given by 3.141 and so on. I don't know the value of it. 4 is 4. तो मतलब ये सब इसमें डाल सकते हैं. You will get a very nice answer, which I am not going to do right now because there's no point in doing this. But remember, you can derive this kind of things. You can say mu vector will be equal to n e h. अब hen लिख दो तो अच्छा नहीं लगेगा. You can also write it ne or n or anything of that sort. All right. So this is how you find magnetic moment of an electron. So this is magnetic moment magnetic moment of an electron of an electron. This is inside the atom. You can call this as magnetic moment of a uh, of of an electron. This is of an electron. All right. So this is the gist of it, guys. Recall that the current loop has magnetic moment that is given by the value equation mu is equal to Ia when the current is in this direction in anti-clockwise direction. The direction of field will be outwards. If you treat an electron as a particle orbiting the current nucleus, we see that the electron creates a loop that is around the nucleus. Mu will be given by EVR by 2, which we just derived, and anything that rotates in angular momentum will have V is L by mr. We substitute this here. We are getting the relation mu is equal to L into E by 2m. Magnitude wise ये negative घट जाएगा because both of them will be positive in magnitude. This is in magnitude form. So I hope it's clear. Now general relation between magnetic moment and angular momentum. अब ये भी कर सकते हैं. मतलब we know the general angular, we just realized, right? We generally, the general moment is given by what is the value of this given? QVR by 2. And angular momentum is general is given by MVR. So linking both of them, not just for electron, we can also say for general bodies, general mass and charge, we get mu will be equal to Q into L by 2m. Simple. वहाँ पे चार्ज by 2m आया, यहाँ पे q by 2m आएगा. This is the multiplication factor. I think this you can use anywhere. It's just a very nice application which by the looks of it. All right. Chalo, let's go solve the relation between magnitude and angular momentum. We just figured out here, guys. All right. So now let's find out the magnetic moment of a rotating ring. Where a ring is rotating with an angle, it's perpendicular to its plane with a rotation angle of omega, and the entire ring is positive, plus 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 plus. Everywhere it is positively charged. It's positively charged. So now, if you take a small dq charge here, if I take a small dq charge, and it is rotating with omega, so then the I due to dq will be given by dq into omega by 2 pi. So integration, I'll call this di. So I can say total current also I will find out. So what is the value of mu here? It will be equal to I into area vector, right? So I is nothing but dq by dt. I is nothing but dq into omega by 2 pi integration into area which is pi r square. Here radius r. So so it is the charge flowing into omega by 2 pi, right? Current is dq into omega by 2 pi. If you take a small element, the charge of it will be इसका टोटल चार्ज क्यू ले लो प्लस क्यू ले लो तो टोटल चार्ज क्यू विल बी फॉर 2 pi r length. So for a dr length, what will be the for a dr length? I am not taking dr length. So dr length dq will be there. If I do the whole thing, I will get dq is equal to 2 pi dr. एक मिनट मैं कुछ तो कर रहा हूँ यार मैं मतलब कुछ तो कर दिया देखो it is rotating with omega. All right, the total q charge is distributed across the entire length, so I can say lambda, the charge density, will be given by q by 2 pi r. So this dq charge will be given by q by 2 pi r into dr. The dq value is given by this, and now we can say the total angle. So this is dq. So what is current? After seeing this, we can simply say the current value. Just क्या हो गया इसमें Just give me one moment, दोस्तों. We will just be right back. एकदम प्लेस पे आ गई. So we are going to find out the magnetic moment of a ring, of a rotating ring. So how do we take a rotating ring? We are going to take the ring to be moving in this particular direction, perpendicular to the axis as shown, with current moving in anti-clockwise direction. Current, it's a ring, na, so it has charge everywhere. It has charge everywhere. Positively charged, and it's rotating with omega in the counterclockwise direction. तो इसमें हम क्या करेंगे? Let me tell you one thing. If the ring has a total charge of Q, ring has a total charge time period. The frequency of the circle rotation is given by omega by 2 pi, which implies di will be equal to omega by 2 pi into lambda q by L. So this is the value of di. Di current here. The current here will be given by omega by 2 pi into lambda q by L. So this is dx, no, I forgot. Lambda into q by L. Lambda is q by L. Q by L into dx. यहाँ पे q by L into dx होगा. So this is the value of small current di. Alright. Now you have to integrate this current across the entire length. So how do you integrate this across the entire length? It will be equal to omega by 2 pi L into q into dx integration from 0 to L. हो गया. So what is the value we are getting? Omega q by 2 pi L into L, which is omega q by 2 pi. What is the previous answer we got? Q into omega into R is also there. So यहाँ पे current is flowing. Oh, my bad. So this is the di current, right? This is the di current. I just integrated of the current. What is the value of mu? Will be equal to di into area of that vector. Area of the area swept by this wire. What is the area swept by this wire? It is 2 pi x dx. If I take a dx element, the total current which is flowing is that much. And what is the total area? It is making a rotation, right? It is making a ring of radius x. It is making a ring of radius x and current is flowing inside. So in this case, the area will be given by pi x square. So substitute the whole thing. From this we will get omega q by 2 pi L into pi x square dx. Pi and pi getting cancelled, we get omega q by 2L into x cube by 3 from 0 to L. What will we get with this? It will be equal to omega q into L square by 6. Got it. So this is the explanation for this, guys. So that's all for today's short and cute lecture. कल फिल्म में रहेंगे. We'll discuss about the torque. So don't forget, this is Let's Crack JEE in English channel for you guys who have trouble understanding Hindi. So share it everywhere across to the people who have trouble understanding Hindi. All right. So that's all for now, guys. Adios, amigos. Don't forget to use the code NSS1. Subscribe to the channel. Hit the like button. Hit the comment section and hit the bell icon for notifications. So that's all for now, guys. Until next time, see you.